Assalamu alaikum. Thank you all for joining us and welcome to today's session of the Ramadan Pioneer Series, an initiative of the Dubai Future Academy, the capacity building arm of Dubai Future Foundation. My name is Faisal Kazim and I'll be your moderator for today's session. I'm part of the Dubai Future research team, which is the research arm of Dubai Future Foundation. Before we get started, I'd like to let you know that we'll be taking your questions and answering them live. And we will have a dedicated Q&A session towards the end of today's session. So please use the Q&A section at the bottom of the Zoom window if you have any questions. COVID-19 has without a doubt had a devastating effect on our lives, but looking at it in a positive light, it has accelerated our path to the future in many ways. Industries that were going from physical to digital are now forced to change overnight. Today's session is on accelerating business through artificial intelligence, and our guest speaker is Dr. Hassan Sawaf. He is joining us all the way from San Francisco, California. He has more than 20 years of experience in bringing cutting-edge technology from academia to market. He is well recognized in the fields of applied science and machine learning with applications in machine translation, speech recognition, and computer vision. And he is director at Facebook AI. Dr. Hassan will begin with a presentation including real-life examples of the necessity of AI in business. Dr. Hassan, thank you for joining us and welcome to the Ramadan Pioneer Series.
Thank you so much for having me. It's an honor to be here, and yeah, thank you so much for the opportunity. So yeah, as Faisal said, I'm going to be talking about artificial intelligence in applications in business, and where artificial intelligence is essential to scale business in global expansion, in security, in improving user interface design, cost saving, and other things. So I'm gonna start jumping right into actually taking a few examples. I think we learn the most when we see basically examples in front of us. So I'm gonna start in talking about a few use cases, mention some of the companies which are publicly talking about their experiences in machine learning. So the first example I have is translation. So expanding reach across country boundaries is an important use case, and we cannot do that with humans anymore because of the amount of data which we have to deal with and the traffic which needs to be dealt with. So I'll give you a couple examples out of Facebook and Google. So 4.5 billion translations have to happen on Facebook on a daily basis. And that was last year. In this year, it's actually even many more. For Google, we have 100 billion translations per day, which are happening. So the reason why we need that for these internet companies is that the languages of content versus users is very different. So if you look at on the right-hand side of the table you see in front of you, you see that English content is still dominant in the internet. So you have close to 60% of the content is English, followed by Russian 8%, and then continuing with Spanish, etc. So if you look at the right-hand side, you see the languages, the users' languages on the internet. So only 26% are basically English speaking, and 20% are Chinese. And if you look at Chinese on the left-hand side, it's 1.3% of the content is only Chinese. So the mismatch about users wanting to find content in their language versus what is out there in the internet is drastic. I mean, if you look, for example, Arabic, we're talking about 5% of the internet users speak Arabic. And on the left-hand side, you don't even see it in the top, I think that's top 10 here. So you see the mismatch here. So machine translation is very critical for this. And so that's for the internet content. But also Go
I just
ahead.
had a question. Sorry, I just had a question on that. So, you know, I think it's a very, very interesting comparison, and especially when it comes to Arabic. So I often use platforms like Google Translate, for example, for Spanish and for Arabic. When it comes to Spanish, Spanish speakers tell me that the translation is perfect, it's spot on, but
Mm-hmm.
only sometimes maybe it mixes up male and female. But
Mm-hmm.
with Arabic, it's less successful. Is this because of the complexity of the language, or is it because of the data that goes into it?
So if you had asked me that question about 10 years ago, I would have told you that it is probably because of the complexity of the language. Today's machine translation systems actually are quite improved, but I think the biggest difference between Spanish and Arabic, for example, into English and back, is the similarity of the languages against each other. So Spanish and English are closer in structure than Arabic is to English, for example. That's one thing. The other thing is still, even though we have a lot of content which we can learn from, for machine translation, for example, to learn the machine translation capabilities, there's still more data, more content, which is Spanish, which we can train on, learn from, as compared to Arabic. I mean, the content is coming basically from the internet. If you look at the table on the left, 4.2% is still so much more than, I think, 0.9% or wherever the Arabic is, for example. So the amount of data which we can learn from, train on, is definitely different as well. So that's another reason. Complexity of the language is still a problem. I'm not saying that it is completely gone, and Arabic is a simple language, for example. It is not. Arabic has another issue actually. Arabic content, when we say Arabic content, we are talking about modern standard Arabic, about Arabi Fusha, in the internet. But that's not all the Arabic there is out there in the internet. We have all kinds of dialects in the internet there as well, which increase basically the complexity, the task. So you could theoretically consider different dialects in Arabic as different languages. Some people do actually. They say Levantine Arabic, and they say Egyptian Arabic, and they say Gulf Arabic, etc., etc. The challenge is here is again that even those, actually this is a continuum. People might actually mix Levantine, Egyptian, and Fusha together, for example, which makes it more complicated to translate that into English and back, for example. So what to pick from the internet content, even in Arabic, to train on, to learn from, is a challenge for machine translation companies.
Makes sense.
All right, I'll continue with machine translation. I'm gonna stick to machine translation for a couple slides here. So cross-border trade is also utilizing machine translation intensively. So eBay started in 2014 to use machine translation to enable queries of potential buyers in Russia, for example, to translate these queries automatically in other languages where the inventory is coming from, like German or English, etc., and translating all the result set, which is basically being found, back into Russian to the potential buyer. That enabled, I mean, at that point I was at eBay actually, that enabled not only to open up new countries where eBay was not there yet, like for example Russia, where we have started, but also enabling countries where eBay is already existing, to increase the inventory for that. For example, German people were able to find inventory from the US, from UK, etc., when they are doing their queries in German, for example. That is a big deal. I mean, if you think about Cross-border trade increased into 20% after introduction of machine translation in 2014, where we had translating daily billions of queries and hundreds of millions of product postings, which is a big deal. So, and today, if you look at what that translated into, it basically increased the cross-border trade by 10% for eBay, accounting for roughly $1.5 billion. And it is an equivalent to reducing the distance of the countries to each other virtually, obviously, by 26%. So we basically brought the worlds together a little closer by 26% using machine translation. eBay started with this. It was very successful. Alibaba took over the same concept. Amazon is doing it. I think today, when you think about cross-border trade, machine translation is part of the plan. Another use case is user manuals and employee training. Ford is doing that, Volkswagen is doing that, and other companies as well, of course. But those two companies come to mind for me first. They use machine translation to enable employees to maintain cars, to translate instructions for engineers and factory workers to be able to like build the cars very rapidly. So training is a big deal in these businesses, and can slow down the productivity of the employee. And using machine translation enables them to do that faster. So Volkswagen uses machine translation to translate into 40 languages. They translate up to 1 billion words annually. And various car manufacturers, Ford, Volkswagen being some of them, but also a lot of Korean companies, etc. They use actually real-time translation in chat to communicate across locales and languages, which is also a very important piece. Subtitling comes to mind thereafter. I mean, if you think about how much content in videos we have and how much of it is available in our languages, we are seeing only part of the world. Netflix has that issue, for example, that they are basically in 140 languages, and roughly 85 to 90% of the content is still English centric. So wherever in other countries where you are not English speaking, the content is much smaller, which you can basically choose from. Now, using machine translation is it's very complicated, especially if it comes to content like videos, movies. So in April last year, Kathy Rukni said that she works at Netflix, said that they're investigating machine translation, but they're not ready to use machine translation by itself yet. So they're continuing to keep an eye on this one. But this year, I mean, basically things changed. Quality of machine translation started to be more effective. And for example, if you use machine translation now as a workflow, inside a workflow to do human translation, you increase the efficiency of the subtitling much more. And not only that, but also you increase the consistency of how subtitles look like quite a bit. So companies like Tarjama, for example,
Tarjama's new platform,
you see, for example, on the left-hand side,
accelerated experience. Tarjama works on delivering entrepreneurs, startups, and enterprises.
So you see the video on the left-hand side. You see basically that speech recognition
new platform
can
for
do
new tech-driven, automated,
the transcription of it, and then basically you see the translation coming out of the machine translation. So the editor, the human editor, does not need to work everything from scratch. the machine can do the speech recognition and the machine can do the machine translation, and the efficiency and the consistency increases quite a bit. So yeah, companies like Tarjama are helping quite a bit in that field.
How long do you think it will take for machine translation to be able to do this without any human intervention?
That's a good question. So the research teams, we are working on it intensively, that we can do that. The challenge is that it's not only that you need to translate the words, but also you have to adapt the cultural nuances from location to location. Sometimes even the same language, depending on where the content consumer is, you might actually need to like adjust it a little bit. If you're talking about, even if you're talking about UK versus US, it's not the same English, not about the language, not about the accent, but about also the cultural background and how what is funny needs to be translated. And sometimes something which is funny in the US is not funny in other English-speaking countries, or something like that. So there is not only the actual content which needs to be translated, you need to do some kind of transcreation. We call it transcreation of content, which is a big deal. So we are working on in the research side, we are working on that, which is still ongoing. And I think we might need another 2-3 years to see the first maybe products which can be considered ready to use. What we are also working on is dubbing. What we could do is, so we have prototypes in research where you can basically see people speak in the language they want, even though they are basically in reality speaking only English, for example, or something like that. So that dubbing concept is also a big deal, which the research community is working on. Dubbing might actually be faster to come than subtitling, because we have more control over basically, I mean, the written text is up for scrutiny more than the spoken, actually, for some interesting reason.
Interesting, thank you.
Yeah. So the next thing I'm going to talk, now we're moving away from language translation towards other use cases of AI. Global logistics uses AI intensively as well. So for example, in Amazon retail, we used to, or they still use AI intensively in many locations. One of them is demand forecasting. To be able to deliver on the promise, to deliver something in a day, the inventory is, even if you look at only the US, the inventory has to shift around on a continuous basis. We need to move the inventory closer to where the potential requester is going to be requesting the item, for example. So you see basically that the inventory is a living thing, and demand forecasting is a critical component to basically do this optimization. So yeah, optimization of paths and so forth is very important for the logistics. And we are using also robots inside the warehouses to increase that efficiency even more. So the people who are working in the warehouses are much more efficient. Actually, they are even more safe because they don't need to, I mean, the need to use heavy machinery reduces with using robots, which means you're reducing the risk for the workforce inside the warehouses, for example. So you see on the right-hand side, these robots, we call them Kiva. They basically move around in the warehouse and move inventory to efficiently together. Integrity is another use case which is super important to use AI in. I'll give a few examples in this. So Facebook I can tell you about Facebook the most right now. We have a lot of people who are helping moderate content. We have 15,000, and that was 2019. We have now, I don't know exactly, 30, 40,000 people who are working on things like hate speech and fact checking and so forth. So, and we basically, um, even with all these people who are doing that, we don't have enough yet. So we are continuously hiring more people and partnering with professional fact checkers and etc. But NLP tools help these people to be more effective, more efficient, to basically identify whether there is a chance for hate speech, for example. We use NLP tools to identify that. Something else which is critical in this context are deep fakes. I mean, you might have heard that term. You look on the right-hand side, you see basically on the top two ladies. They look quite similar, but they look like they are different people at the end of the day. And if you look to the right-hand side, basically what happened is some AI algorithm took basically the left-hand side as a reference and overlaid this picture which you see inside on it, and basically generated a new person out of it, a new persona. You see that in videos as well in the bottom. Sometimes it's difficult for us to identify which one is the fake and which one is the original. So to fight that or to identify that, you need AI as much, because this kind of content is growing in amounts, and we need to worry about this one. And Facebook started a deepfake detection challenge, which means we are basically trying to have everyone think with us. I mean, this is a problem not only in Facebook, but in Google, in everywhere where there's videos and photos involved. We have to like worry about this thing. So we're basically putting up a challenge for everyone to think with us on how to address this issue. I mean, that's that. Then AI is being used in personalized recommendations, for example, at Google. So we do, Google does automated bidding recommendations. They do ad creative recommendations, keyword recommendations, audience reach recommendations. So if you are using the advertising, for example, it can suggest to you on what to do with your advertising, which you're running on Google, to be more effective, which keywords to drop, which keywords to add, where to position it better for, if you position it in certain locations where it's gonna be better for you, etc. So AI can help with identifying that for you. Next thing is personal assistants. You have a lot of companies now working in this field. You have Apple and Siri there. You have Google and the Google Homes there. You have Amazon and their Echoes and Alexa-enabled devices from inside Amazon, as well as partnering companies. Samsung is doing the Bixby assistant. And then Facebook is working on assistants as well in their new devices, the portal devices, for example. So to be able to do so, there is a lot of components, technologies which are necessary. Speech recognition being definitely one of them. We need to have these machines understand our language, but understanding is not only translating the acoustics, the audio into text, but also understanding what is the user intending? How can I help this user? I mean, if I'm asking for a train ride to a place, and I'm asking how much it costs, the system needs to understand my intent, needs to understand the locations which I care about. Maybe you can personalize information to me. Maybe I'm someone who need special assistance, for example, to get into a train and to get out of the train. I mean, all these things have to be looked into when you're looking at these personal assistants. And then each of these, in particular, the Alexa framework, there is a lot of applications. So you have the Alexa skills are beyond 50,000 skills right now. So how to basically match the people's needs to any of these skills, for example, is a big and complicated task. Then the other thing is also, you see many of these devices are starting to have screens and cameras. So it's not only voice, how you communicate with that. If you have an Echo Show, for example, you can show it devices and ask information about things you have in your hand, and it will tell you basically information about it, for example. So multimodality is starting to get into the mainstream as well, where not only the modality of audio and speech is there, but also the vision and visual feedback with the screen. The next thing I want to talk about is customer service chatbots. You have a lot of companies want to be with their customers more intensively, or available for them all the time, so to say. And chatbots are a critical component to that. So when you have a chatbot which automatically can answer questions, for example, about in insurance, Gelco is using that for their customers. They can ask about policy coverages, or they can ask about billing information or documents like insurance IDs, etc. You are available to the customer all the time. You don't have like 8 till 8, for example, availability. You have a 24/7 customer assistance availability. And those customer service chatbots are getting more and more intelligent as well. Some of them are text only. Some of them have also voice interface. So this is something. So the banks are more and more using it. Insurances are more and more using it. You see cable companies are starting to use it more and more. So it's getting into a place where the customers are starting to assume that a company has to have that kind of capability. And that's definitely driven by AI.
Regarding chatbots and other types of AI, one of the questions also we're getting in the Q&A section is, when it comes to these technologies, do the smaller companies, startups, can they benefit as much as the larger companies? Because a lot of this has to do with learning and data. So does this mean that the largest platforms with the most number of users will keep getting better and better, and the smaller ones will get worse?
No. So that's a good question, though. But no, actually, I think, so the amount of training data for these chatbots are actually relatively low. I mean, these chatbots are being built in such a way that with relatively small amounts of data, you can start building really good chatbots. So the amount of data is not necessarily the only metric you should look into. And in my opinion, actually, these chatbots allow small companies which don't have the resources to staff a call center 24/7, so to say, appear like a large company as well. So at the end of the day, what kind of company is behind this chatbot is not necessarily clear to the user. So it might be a company with 10 people only, and they have a great chatbot, and you might have a huge bank with hundreds of thousands of employees and have basically a similar chatbot or a worse chatbot to that extent. So the amount of data, yes, the amount of data helps improve, but this is not the only metric. The design of the chatbot and how it's basically built to interact with the customer is actually more important than the amount of data which you train the bot with. Next thing I want to talk about is cashier-less shopping. Amazon is not the only company now which is starting to offer this, but Amazon definitely was one of the, or actually the first companies which implemented that. So what does that mean, cashier-less shopping? What this gentleman, which has his back to us, is doing is he's checking into a store. So this store is, I think, in Seattle. They basically, you just have an app running on the mobile device. You check in by scanning this mobile device. You go in, pick up your food, your whatever item you want to purchase, put it in your backpack and leave the store. No need to go to cashier. No need to, touch anyone or communicate or interact, etc., etc. And that is so. The reason why Amazon Go was established was actually to reduce friction between for the shopper. So usually we go in. Yes, we want to have time to browse. But when we pick our stuff, we want to actually, we want to leave. We have our stuff. We don't want to wait in line for the cashier to be ready for us and then do the payment and give a credit card and take it back and sign somewhere and this and that. There's no need. There is no need for that friction if you can basically do that all in a fully automated fashion. To be able to do this, we have in each of these stores, you can see that on the right-hand side, a huge amount of cameras watching basically everyone and what they do in the store. And basically AI understanding basically the intent. If someone is taking a product, looking at it, reading maybe the ingredients and putting it back, I don't want to charge that customer because he didn't buy that. Or if I take the item, give it to someone else and that someone else puts it back, I don't want to charge neither me or the other person. It should be basically, should be understanding what is happening. So these cameras basically allow the AI to understand the behavior of the people and what their intent is, and then basically make the right decision when they leave. It was funny actually when Amazon Go started. I was at Amazon and we were asked to go in and confuse the system, and it was initially it was sometimes possible, but by time it gotten really smart. Now, since recently, it's not only packaged goods which can be purchased through these Amazon Go, but even vegetables, for example. You can go and pick up tomatoes and put it in your bag and go and all of that. So this is even a huge step forward, because packaged goods are relatively easy to identify, but as soon as you're talking about a tomato or a red apple and stuff like that, you start getting more confusion as a human even. So, and the AI is doing an incredible job there. So this is something which I think the team can be really proud of. Gerard Medioni is the chief scientist behind this. So.
Very interesting and definitely very relevant during COVID-19 when everybody is going for touchless shopping experiences. So do you know if these cameras and sensors if they're proprietary to Amazon, or is this something that, let's say, another maybe smaller retailers want to do something similar, that they can also basically imitate them and do the same?
So the cameras, I have to admit to you, I'm not 100% sure whether the cameras have to be Amazonian cameras or not. But as it comes to the smaller retailer, Amazon does not want to develop that just for their own stores. Definitely. At the end of the day, The goal is to test it out to be good with what they have, but at the end of the day, it's supposed to be a service for any retailer to implement that kind of experience in other locations as well. So that's definitely part of the long-term plan, medium long-term plan. So it's not that far out. If a retailer is interested in doing that, I bet with you that if they approach Amazon, they're gonna try to support wherever they can, or at least give some kind of idea on when that is available for others. The next thing is what I want to talk about is fraud detection and counterfeit merchandise. Fraud detection is a big deal. If you think about how often credit cards are stolen, are being used basically to buy things which, I mean, someone basically using a credit card number to buy things in your name, and how often banks have to like deal with that, or companies like eBay or Amazon. So eBay worked on that, and they recognized 40% of credit card fraud cases with high precision. That doesn't mean that only 40% of the situations are caught by eBay. That means that basically 40% are identified by AI only, and basically other use cases, there is a combination between machine learning, like the AI, as well as a human, as a combined system, so to say, to identify credit card fraud cases at eBay, for example. So that's one thing. The other thing is counterfeits in eBay is a big issue. Of course, not only eBay, everyone who is basically setting up a marketplace for buyers and sellers to come together, you say you have that issue. But eBay is a big marketplace like that. So they implemented technology to identify counterfeits automatically. If I'm seeing a Louis Vuitton, chances are high, on eBay, chances are high it is not a counterfeit, because AI reads out all these counterfeits, identifies them by computer vision methods and other methods to identify basically whether it is something which is okay to be put on the marketplace or not. This is an important component to increase the trust between the marketplace and the buyers and sellers, obviously. So the smart visual voice assistants. I mean, I mentioned earlier that voice assistants are getting more smarter and using more modalities than just the voice. So Facebook is starting to do something with their portal devices, which is very interesting, where basically they identify instead of basically having the situation on the right-hand side, you see the girl was talking to her aunt or grandmother, I don't know. Look at me, I'm dancing. And then basically she disappears because, you know, the camera is not moving with the child. But then the portal devices have a camera which basically moves, identifying where the pose is and the person is who is in front of the camera, and following the person around. So I use it quite a bit. My mother is in Germany and I am in the US. And when we talk to each other, oftentimes I'm in the kitchen doing something there, and my mother as well. And we don't need to stand in front of the camera and just not be able to move. We can do whatever we do, and we basically live our normal lives while we can basically interact with each other and see each other. So that's a good thing. And this is enabled through AI, obviously, because then we have also augmented reality features in these devices where you basically, if you want to do some fun things where you want to like embed the real world with some like comic figures, for example, etc., you need to understand on how to mesh the virtual world with the real world. And to be able to do so, you need to understand what is there in the real world. So you see these augmented reality features in the on the left-hand side of the slide here. Okay, the last use case I want to talk about is disease management and disease control. So in particular, in the context of COVID-19, this is on top of our minds, and it's a very important piece. So AI helps in many ways, and I have only 3 ways I'm mentioning here, but there's tons more. One is you can use AI to build a cell phone-based test to augment and support healthcare workers. So what do I mean by this? BRXeathe, which is the website to the right-hand side, you can see is an effort between multiple machine learning scientists and physicians in Johns Hopkins, Georgetown University, and other universities which are starting to join, to have an app on your phone where you can basically get tested about potential pneumonia coming from COVID-19 before you go and see a doctor. So you can basically self-test using that app and see basically how high the risk is. It's not enough to fully replace the actual test, of course, but it gives you a good indication whether how critical is it to go and get actually the real test to be done. So that's a good thing. The other application of this app is that healthcare workers can start identifying risk factors of patients. So we can basically identify what is the order where we want to have people come into the hospital, or what is the order where we want to have people get connected to the breathing machine. What is it called? The ventilators, right? So that's basically what that is. Yeah, then we have drug discovery is a big and important component. Drug discovery, instead of basically doing a lot of tests like we did in the last 20, 30 years with experiments in the lab, we can do a lot of things fully automatically by simulation using AI, and then basically focus on the things which have a high probability of success rather than investing in everything which we are trying to think of. So drug discovery is a big deal. Another part which is helping in the disease control is forecasting models for disease spread. If you can basically identify through machine learning models where the chance of forecast basically where the chances are high that someone might get sick, and basically take whatever preventative measures to basically reduce the chance of getting basically people sick from each other, so to say, then basically that's also
it's kind of similar to I guess what Amazon's doing with managing inventory and demand, but in a healthcare context. Lives.
Yeah. The only thing here, the big difference here is though that there is much more unknowns. I mean, inventory is known, is completely transparent to the AI. With disease forecasting, there's a lot of unknowns. You don't know who is sick. So there is that dimension which makes it a little bit more complicated though. All right, so those are the use cases I wanted to present. A little bit of technical background, just to basically, I mean, I'm gonna go quickly through this. What is AI and ML? Artificial intelligence and machine learning. AI covers topics like reasoning, knowledge representation, planning, learning, natural language processing, perception, motion and manipulation, social intelligence, which is a new thing, and general intelligence, which is a thing which we are all aspiring to, but might take a couple decades still until we get there. AI approaches include symbolic, sub-symbolic, and statistical learning. So symbolic methods or symbolic approaches are basically where you define rules, where you say, if that happens, then do this, so to say. Statistical learning is when you basically say, okay, these are my examples, the system has to learn it, find out basically how to define these rules fully automatically. Sub-symbolic means that you basically implement something which translates the real world into something which is more abstract and then work on the abstract level. So you basically, if you think about language, the language can be translated into something more abstract. If I'm saying ball and say it in English, I'm thinking about a physical object, a semantic concept, and then basically work from there. So when we talk to each other about something abstract, then that's most of the time sub-symbolic in our situation. So that's the semantic level to some extent. Then machine learning accelerated the field of AI drastically. In particular, since neural approaches with complex architectures got viable, like what we hear in the news is being called or mentioned as deep learning, right? Machine learning can often replace classical coding of a solution in source code in a programming language by teaching an algorithm with training data instead. So what we used to do, sitting behind the computers and programming a certain solution, today you just take the algorithm. If you have enough samples, you can train an algorithm instead of basically sitting down and coding. This is basically the next step of computing. A hot topic in machine learning right now, for me personally, in this context, is self-supervised representation learning. Basically, what can we do? What kind of algorithms can we build where we just give it data and it will learn the structure out of this data and be able to learn concepts which it didn't necessarily have need a teacher for, so to say. So if you look at basically the AI ML, what it is, you can basically layer the different things which are relevant to machine learning so that we can offer them. So we have the machine learning infrastructure, things like mobile accelerators like chips on the phones to make machine learning faster, server-based accelerators so that GPUs can calculate machine learning algorithms faster, and also general server hardware is getting more and more good enough for machine learning. Then we have core machine learning functions as a layer on top, where we see unsupervised learning, semi-supervised learning, supervised learning, reinforcement learning, supervised, and other kind of learning. I have supervised learning here twice. I'm sorry about that. So, so the different learning techniques, so to say. Unsupervised learning means that you give the machine learning and algorithm data, and then it will automatically learn the structure out of it. Supervised learning means you basically tell it each fact in a very concrete manner. Like, for example, if you think about language again, which is simple for us to grasp, you can say each word and what it means in translation. Semi-supervised is a mix between the two, where you say, the translation of this whole paragraph is, you see it in English, you see it in Arabic, for example, but I'm not going to tell you which word translates into which. And by time, basically, the system will learn on, okay, this word means that, etc. Because it gets enough data. If it gets enough data, it can basically extrapolate the alignment and knowing more details elements. So elementary AI functions are things like planners, computer vision, speech recognition, entity recognition, machine translation, recommender systems, things which are critical and can be used basically by us as consumers. And then we have more complex AI functions, things which are, I mean, multiple AI systems, multiple AI components put together into a complex situation. Robotics is a very clear application of it, but also multimodal assistance, voice assistance, speech translation. Those are using multiple core technologies, multiple core elementary AI functions to do a solution.
Dr. Hassan, I'm sorry to interrupt, but I think because we're running out of time and there's so many great things to discuss, just wanted to give you a heads up, maybe a couple minutes more.
Okay, good. So this is a training algorithm. You can basically give the system training data. We basically do training. A trained model comes out of it, and then we can do inference. You can expand it with the human in the loop. You can expand it by basically feeding the system the results back into the training system to do better learning. I'm basically almost done. So why is AI important for us in business? Because the data, it's basically scale all the time. Data, the content, user traffic signals, speed, time sensitivity, security. We have to be quick in response to threats, and the cost. And what do we need to worry about when we use machine learning? So we should think about security and safety. We should think about privacy issues. We should think about bias. This is very important as well. Modeling issues. We should not expect that the machine learning is always perfect. Definitely not. Potential socioeconomic imbalance. So, I mean, you need to make sure that it's democratized. And then also bad actors. I mean, we could theoretically see AI, or we are seeing AI being used by bad actors, and we need to like circumvent that and fight it. So this is an important thing. Yeah, that's it.
Thank you very much, Dr. Hassan. Thank you for
Sorry, it took longer than I was planning to.
Not at all. There's so much to talk about always with AI. Thank you for giving this informative presentation. You've covered a broad range of topics within AI and highlighted how much value AI can bring to us in business, especially when you need scale, speed, and security, which is exactly what we need during this pandemic. So given we're almost out of time, I will try to address the questions by combining the most popular questions. Number one is around hacking and cybersecurity. So especially on yesterday's session of the Ramadan Pioneer Series, one of the topics that came up was the rise in hacking activity during COVID-19. So what role can AI play in preventing hacking?
So, I mean, there's a lot of threats which can be actually worked against using AI and machine learning. At the end of the day, hacking is something what we call it's an anomaly. It should be an anomaly, and it basically should be identified by machine learning algorithms. So, and hacking comes in multiple ways. I mean, but in most of them, AI can either be the technology to support, or actually a supporting function to it. So, yeah, I mean, this is a research topic which continues to grow, because hacking gets even more intelligent as well. The people who are doing the hacking are using AI as well, which means the people who are fighting against hacking have to be using AI as well. So things get a little bit intense on that end. But it's definitely something you should think about if you're fighting hackers.
Thank you. And I guess everybody's favorite question: what's the role of humans in a post-AI world? So people are worried about jobs, especially when it comes to maybe translators. Several people have been asking this question. So what's your opinion?
Mm-hmm. So the question about jobs is actually not new. People think about it today. Maybe it's new, but I started in machine translation 25 years ago, and basically my mother is a translator, so she basically does translation. I did some translation in Germany as well. So people think that basically because machine translation exists, we are out of a job. It's not the case. At the end of the day, the machine translation is going to be good for, in double quotes, simple tasks always. But then the human translator has to dig in. That's number one. Number two, the machine translation has to learn from someone. That's number two. Number three, some use cases are not even feasible for human translation. If you think about how fast do you need, how big does the army need to look like, which translates to just translate eBay's inventory. We have 100 million items on a daily basis getting into the marketplace. What kind of army, where, there's no way. So you're basically enabling more the need of translation. So it's actually funny that due to machine translation, the need for human translators is increasing because the world is more global and the people need for some use cases always a high-end human translation. So there's that. Now, talking about the jobs, in my view, the application, the need for AI is, no, the AI should be an enabler for new jobs. That's how I see it. So same like when machines came, we basically didn't need to work on the like low-level work, and we can focus on the higher-level work. We have the same thing with AI. It should enable us to be able to focus on the more complex problems. Our brains is going to be thinking more abstractly now about problems, etc. So basically, same like the calculator when it came and did math for us, and we can focus on higher level math. Same thing with AI. AI is just a tool at the end of the day. So that's how I see it from my perspective. The change is going to be that some people have to relearn the way they work. Even human translators, for example, why don't you use machine translation in your workflow and increase the quality, increase the throughput you have by a factor of 2 or something like that, for example. So instead of thinking about it as a competition, use it as a tool, and then you will see that the increase of value for humanity and for the workforce is actually higher.
Thank you very much. Unfortunately, it looks like we're out of time. I definitely like your view of AI augmenting humans, allowing us to do more. Thank you very much, Dr. Hassan, for this informative presentation. And this is actually our final webinar of the Ramadan Pioneer Series. So on behalf of Dubai Future Foundation, thank you all for joining us in the season of the Ramadan Pioneer Series 2020. It's true we haven't gathered at the Office of the Future as we normally did, but moving virtual has allowed for people from different parts of the world to join us. So we had over 4,000 attendees from over 90 different countries. And this is an example of the opportunities that we create at Dubai Future Foundation during COVID-19. For everyone who asked about the full session recordings, we will release them after Eid, inshallah. And we will notify you by email and social media. And a special thanks to the Dubai Future Academy team. Thank you all for joining us. Take care, everyone. And I wish you all Eid Mubarak.
Eid Mubarak. Thank you very much for having me.
Thank you.